Okay, thank you. So, I guess the most number of students will be there. So, I will start. If others join, they can join. So, no issues. So, so far we will discuss. Today is the fifth and sixth lecture of DBMS. It means the database management system. So, previous class we discussed with the problems in the file system as well as the which reasons that leads to the DBMS instead of file system. So first issue in the file system, structural and data dependence. So structural dependent in the sense that the altogether we have to design out, we have to structure a database, then only we can input data in the file system. But when it comes to DBMS, we can easily customize the structure of the DBM database management system as well as the data dependence. So changing a data from character to string or string to number. Likewise, the data types changes also easy to change in DBMS. So as well as the data redundancy. So what do you mean by data redundancy? Can somebody tell, or you can put it in the chat? What do you mean by data redundancy? Yeah. So who's this? Jay Prada. Yeah, good. So same data, same data, when we store that data in different places, but actually that same data, right? So it called as a data redundancy. Through the data redundancy, like when we store again and again the same data, it leads so many issues. One of those issue is data anomaly. So data anomalies are normally that the same data changes didn't update to all the different locations, right? So when you have some files with name and phone number, another file name and address, another file name and job title. When someone change his name, we have to change altogether that 3 files. Okay, if we didn't that the name data is stored in 3 locations is called as a data redundancy. But data anomalies in the sense, using the data redundancy, it leads to the if a change that one person change his name, his or her name, then we have to update all 3 files. Okay. So as well as the database concept we discussed in the previous lecture. So today's lecture is very important. So far we discussed with theoretical parts of DBMS and database, right? So from today onwards, you have to be focused on what we are going to learn in today's and future lectures, because those things you are going to apply in your real projects. So when it comes to projects in next semesters or in next years, so you have to create your projects. When it comes to projects, the language, the front end, back end, the languages may be different. Like when in your first year you learned, I got some internet connection issues, but if I leave, please be stay. I will join this session. Okay. Okay. So wait, I will check. If I leave, please stay in the session. I will join. Now, can you able to hear me clearly? Is now also the issue is still? Can somebody tell me? Okay, okay. So I changed my Wi-Fi. So let's see. If you have any issues, just message or unmute me. If I didn't see your message, just unmute and tell me. So the session is important. So if my voice is lacking, you can't hear me properly, right? So if in the lecture, if my voice is breaking or lagging, please message, or if I didn't see the message, please unmute yourself and let me know, right? So yeah, so today onwards we are going to have some practical means like the diagram wise, and we have to deal with the real world or real time scenarios. Okay, so you have to understand clearly, then only you can create a database properly, right? So when it comes to DBMS, so in your future, so you heard about creating projects, mini project, in your seniors, or I don't know whether you are familiar with this word. Do you have any mm, projects in your previous semesters? You are in the second semester, right? So do you have any project like HTML, CSS, or C#? Yes or no? Did you work any projects in your previous? Yes. Okay. So, which language may I know? So, if you already familiar with the SQL, DBMS, or database creation, the database part, like using SQL data. Okay, no. So it's new. So okay, no issues. So in this semester onwards, you will have some projects, right? So the language we call in the software, we called two types of languages. One is front end language. So front end language in the sense what you can see. So when we take a website, what we can see is created by the front end languages. There are a lot of front end languages, as well as nowadays we use frameworks, front end frameworks, Angular. The base is HTML, CSS, Bootstrap is the base front end languages. But nowadays we used front end frameworks, Angular, so Vue.js. So likewise, there are a lot of front end languages, as well as backend. So backend means they are the one directly interact with the database. So let's take if a so I'll take a marker, right? So let's take, there's a database, right? This is a database, and that database is interact with backend. Okay, so that backend interact with the front end. So the front end is the one viewers are viewing, like using the front end languages, that HTML, CSS, the designings, animations, that in your university website, there are images moving and the boxes. Within the boxes, there are some text we called as a content. So likewise, those animation and designs are using created by front-end languages. So the backend, so basically we use backend languages as Java, Python, C#. like those languages we used as a backend. So backend are the one directly connect with your database. Okay. So is still my voice is lagging? And okay. So if my voice is lagging, please hands up in the reaction. Please raise the hands up. So I guess who's that? Safhan. I think you in your side you have some network. Sometimes lacking. Okay, is that okay to continue my lectures? If that lagging is worst, please let unmute yourself and tell me. Okay, if that okay, I will share the recording as well, so no issues. If you can manage to hear me, it's that fine, right? So I just continue, but if you can't, that lagging is worst, please unmute yourself and tell me. Okay. Okay. So yeah. Okay. So now we are in the database designing part, right? So here we have to create a database in our software. So that's we called as a DBMS. So a software we have to use to create a database, right? So when it comes to database, so my writing is very poor in this pointer. So I'm new to the Zoom. So please excuse for that. So this is a DBMS, right? So the DBMS is a software. So you have to work with the software to create a database. So the database part is real time. So in university, so the students details, your attendance and your names and your address. So those datas, so what is the database? It's a collection of real related datas, right? So those collection of related datas are real world issues, right? So we have to connect those real world problems into software. Then only we can move to this as a project. So you can even wonder, you heard about creating project, mini projects. Likewise, in your next years, you will have many projects to do. So on that time, you may wonder, how can I create a project, or how can I choose idea to project? So it's nothing. So whatever the thing in our real world that we have to convert when it comes to convert as a software, we call it as a project. That's the one. So nowadays also that fuel pass, that's also a project. That's a web application, right? So the government find the solution for a real world issue. So when it comes to database in the fuel pass system, so what's the database? Database of a person IC number, full names, and the address, and the vehicle numbers and vehicle fuel types and chassis number. So those datas are related datas, right? So all together they collect those data and put it as a database. Okay. So those using the database only, they can communicate whether a person's using the person's address as well as using the person's vehicle fuel type, if that's diesel or if that petrol, then only they can arrange the fuel to that person, right? In the future, they are planning to arrange fuel to that person according to the data. So, so database is the basic. So we have to, first thing we have to create a, so we have to design. In the previous lecture, the last lecture I discussed creating a database. So we have to create a database clearly. Then only we can transform that database into software. So in the fuel system also, if that creating database in the sense, what are the data we are going to take in? So they create those database or design those database earlier. So let's take, if that person is failed to get your address in that web system, but what's the issue? So they can't, they can get your IC number, name, fuel type, vehicle, but if they forget to get your address, they can't allocate you to the near petrol set or near fuel station, right? So in designing database, you have to focus on what data we are going to take. Then only you can update those database into software as well as those software all together as a project. It will work properly, right? So this is a common general term. So in today's lecture, we are going to discuss about data modeling. So before DBMS, creating a DBMS, there are some small parts. So each small parts, when you understand those small parts correctly only, you can create a database properly. So the database and the data modeling parts are manual. So manual means either you can logically think what are the data and write somewhere on the paper, or in advanced there are some designing tools to create database, so you can create those designs. Okay, so we have to see what is data modeling and what is data model and the importance of data model and basic building blocks of data models, and finally business rule. And in the final 30 minutes, so which means 11:30, you'll have a quiz. Oh, quiz means this is a group work. I will get you the final presentation final answer using some Google Docs. So you have to submit your answer. Then I will mark you. Okay. So in that group work, I will put you into a breakout room. So quickly you have to submit the answers within 30 minutes, as well as put your register numbers as well in that document. Okay. So today's lecture is will be cover up these sections, right? So first thing we have to discuss in today's lectures is data modeling. Okay. Okay. So data modeling in the sense, this is the first process of database design. Earlier, the previous lecture, we discussed about database design, right? Designing a database. It may be either logically that in your mind, or you can thinking what kind of database you are designing, but better to write out somewhere or better to use some designing tools. I will show you how can you design. Okay, so first thing you have to understand the theory parts, then only you can successfully design a database, right? So first thing, data modeling. So data modeling is the first step in the database designing. Okay, so why data modeling is using is it's the middle part to the customers as well as the computer database. So you previous slide also, the drawing I did, right? There is a DBMS. So that's a computer application. For that, so that DBMS part, that computer application, we have to convert real world issues to that computer application, right? So for that, we are going to use a data modeling as the bridge between that real world objects and the computer database, right? So data modeling is the data modeling is the one which act as real world issue and as well as the computer database creation, right? So the data modeling is the process of creating specific data model for a determined problem domain. So what do you mean by determined problem domain? In the sense, we can't create data model for all the real world issues or all the real world problem. So whatever the determined problem, then for that problem only we have to create a data model. So in the fuel case, when it comes to fuel database, or when it comes to that vehicle and fuel database, there are lot of stuff to include, right? Rather than the name, NIC number, address, and the vehicle, fuel type, vehicle number, CC number. Rather than that, there are a lot of data to interconnected with the system, right? What are the data which are interconnected to this system rather than these data? I think you already familiar with that fuel pass, right? You may register for your vehicle or your family member's vehicle, right? So in there, they asked for the full name, address, NIC number, and your mobile number in the first. If you then they take your vehicle chassis number, vehicle number, fuel type, like, right? So the determined problem domain, in the sense, there is related data rather than this. What is the related data? They may ask for related data in the sense of vehicle owner, right? When you buy that vehicle, or where did you buy, or that vehicle number plate, register number, the province, that NP, CP, likewise. So there are a lot of data related to the data model, but they didn't include those data, right? Because for the determined problem domain, we don't want that detailed data collection, right? So that's the one we have to think. So the process of creating specific data model. So when it comes to project also, you have to think, if you find a problem, then the data model must be collect the data which are familiar, which are using, or which are involved in that problem only. Okay. So the database design focuses on how the database structure will be used to store and manage end user, right? So database design is focused on the structure, but data modeling is focused on the bridge between computer application as well as the real world object. Okay, so data modeling is an iterative progressive process. So which means if once you create a data model, then if there is any changes, you can again recreate, or you can change changes in your data model. So that means the data model is the iterative process. Okay, so when you finished, once you finalize the data model, that would act as a blueprint. So blueprint in the sense for your house building. So when you take that example of building your house, first thing you have to design a blueprint for your house. Once for designing a blueprint, what you have to do? First thing, you first discuss with your family members how many rooms they want, or where the measurements of each rooms, and where that washrooms, where that welcome hall, where that dining table places. So you have to finalize those things. Then only you start with the draft blueprint. Okay, first you finish your draft blueprint. Then if there is any changes or someone ask more rooms, then you can add. Likewise, in here also the data modeling process is the one we are working as a iteratively. If there is any changes, we can change iteratively. But when we finalized, we can't change. When we finalized, it's a act as a blueprint with all instruments to build a database, right? So after finalized only, we have to send it to the database creation. It means we have to start our DBMS. So when you create a project, it's a best practice before. So normally what we have to do, so I don't think you are familiar with that, but normally our students, when we ask for the project, they will start writing codes in the front end using HTML, CSS, some front end language. They create some user design, then they start with the SQL and create database. Then if they have some issues, they struggle in that database, because they start with the software. First step, they start with the software, the DBMS. So that is not the best practice, right? So first thing, you have to data model using your some designing tools are there, as well as you can use the pen and paper is the best way when it comes to data modeling. After finalized only, you can go with the designing tools for data modeling also, right? So the second thing is data model. So first thing we discuss about data modeling. So it's a process, right? It's the first process in the database design, as well as it's act as a middle layer to the real world object and computer application, right? So data model is a relatively simple representation, usually graphical or more graphical. So in data model, simply you can think as it's a representation of real world data structure, right? So when it comes to real world data structures, it may be complex. So in the vehicle system also, the real world scenario, it's complex, right? There are in Sri Lanka, there are a lot of districts, and each districts there are a lot of fuel stations. But in the real world system, what's the complex is, so when we take the Vaunia the bus stand IOC petrol set, there there lot of the non-Vaunia people. So it means rather than Vaunia district peoples, there are other district peoples also in the queue. So that's a complex real world issue, right? We can't mention those complex issues in the when it comes to database model. You can't make complex issues within the database model, right? So normally we use some assumptions. So the word is important. So we take some assumptions when it comes to software system, because real world, because computers are for still now computers are somewhat behind rather than the human minds, right? They can't react whatever the human reacts, right? So likewise, when it comes to software projects also, we avoid or we assume and we put some assumptions as these are the things didn't happen, right? So in the fuel issue also, they take our address and they take the fuel vehicle types, but they get assumptions like if a Vaunia person, that person's address is Vaunia, they only go to the Vaunia district petrol side. Or if that person is in the Pambamadu, that person only goes to the Nalukulamo or that Verpangulam petrol set only. So these are the assumptions. Based on the assumption only, they collect the data, right? So in the data model also, we can't mix with it. It's a representation of simple representation. So when it comes to real world data, there are a lot of complex issues, but we can't put those complex systems into our data model, right? So don't confuse. I will give some exercises, so you will get clear idea when it comes to exercise, right? So the data model is just using the processing part is the data modeling, the output is data model. So the data model is a representation of simple graphical to the real world structure, right? So so first thing, data modeling. Second thing is data model. So third thing is why do we need this data model? So in earlier scenarios, I told in your senior batches also, when we ask for them to create a project, they directly go to the open the DBMS software to create a database. So why that's a bad practice? Because normally we don't have a ideal mind that whether we don't make any mistakes, right? So if we make any mistakes in middle of the software database design, then it's hard to correct those mistakes, right? So for that one, we have to use a data model. So more than that, there is one issue where one important thing is to create a data model is because the data models are used to represent your organization's objective as a common word. So which means, so when it comes to an organization, right, when we take this university as an organization, so in the vice chancellor, if I am a if our vice chancellor perspective, they only consider with the senior people. So senior people in the sense, if a vice chancellor create a data model, he will create what? Faculties, departments, administrations. In the administration, he only focus mostly with the senior management and senior teams, right? Because his perspective of the organization of as a university, his perspective is different, right? So if a student is creating a database, or if a student's perspective, they only go with the low level. Just they can go with the head of the department, dean, then maybe you can add your batch rep. Likewise, when a student perspective is different, right? So that's why we want a data model, because the data model is the general perspective of an organization. So it includes students' perspective as well as the vice chancellor's perspective either. Okay. So the importance of data model is facilitate the interaction among the designer, application programmer, and end user. So when it comes to database design, there is a designer, right? Designer mean, so they talk about this one, they talk about a larger project. When it comes to a software company, if first thing they want to create a database, there is a database designer who are the one get the requirements, what are the data we need to add, what are the real world objects, likewise. Then the application programmer is the one create database, DBMS, right? Uh, he, he's doing the actual database implementation. He's doing the actual database collection, right? A database data collection. In the final end user perspective, end user one who are going to use the application, right? So we have to facilitate the communication between these three, right? Because end user is the one who are going to use the database. So if we want to miss any data collection, the database designer miss something, then the end user is the one who affect that problem, right? So when a database designer collect wrong format of data type, then application program is the one who affect by that. So using the data model, so let's take an example. So if I want to create a university data system, university database, right? So the end users are the one you, right? The students who use that system, or the lecturers and the students, and the administration people are the one end users. The application programmer, maybe we can hire a software company, we can hire a programmer to create that DBMS. And the designer are the one who, they may be from our university, like the computer unit people, or they may be from another company people also we can hire. So we have to facilitate the communication between those three, right? So for that, we have to have a data model. So when we have a data model, we can easily gather those three people and put the data model. This is the data model. If there's any if there's any correction, so if there's any correction want to needed, so the end user, the students can suggest some corrections within the data model. And if the designer wants some clarification, they can ask using the data model, as well as the application programmer ask using the data model only. If that data model is not there, so they can't communicate properly. So just a logical, so that imagination way, if we talk with that imagination, like these things are, we want, like when students talk, we want some things in imagination way. So there is some conflicts in that scenario, right? For that, data model is the important. And the data model is the communication tool. So I already discussed, it's a communication tool. So using that, you can find some issues as well as you can add some changes. So it's a communication tool between the designer, application programmer, as well as the end user. Also, data model is the one. So when the house blueprint, so the data model act like as a, when family members create some draft model and finalize the draft model to the draftman to create the blueprint, right? The designer house, what we called as draftman, right? So the finalize the blueprint, database blueprint, the data model is the overall creations. So data model leads to the database blueprint, right? So far, if you have any questions, you can ask. So I guess you don't have any questions. So be mind on what are the theories that we so far we discussed. So from this slide onwards, you must be concentrate on this, because these are the things uh, which I going to discuss in the group work, right? So first thing, so far we discussed about what is data modeling, what is data model, and why it is important, right? So you have some overall idea of how far this data model is important, right? So when we jump into the data model, before that, we have to have some ideas of what are the basic building blocks when it comes to data model. Okay. So first thing when it comes to data model is, so far you have some idea, right? There is a real world issue. Real world issue means the lifestyles the day to day life we lead, right? That's the real world scenario. So when all the time I talked about real world or real world scenario, that's the just simple thing. So when it comes to university by bus, so that's a real world scenario. So when your mother cooks something, that's a real world scenario. When I teach you something, so that's a real world scenario. So these are things real world scenario. So we are going to convert this real world scenario as a data model. Why we convert this as a data model? Because using the data model only, we are going to develop some software, right? So first thing is entity. So what do you mean by entity? Entity is, so entity is a person, place, thing, concept, event for which data can be stored. So basically, you can say it's a data. Entity and data may be, have some similar connections, right? So uh, mother cooks something, mother cooks rice. So in here, mother and rice is the entity. Okay, so basically these entities are nouns, right? So lecturer teach subjects. So in here, subject and lecturer are the entity. Okay, so it's a simple thing. So entities is the place or the thing or concept. So event we call it as an entity, right? Second thing is attribute. So attributes in the sense, so we have an entity. So the characteristic of an entity is called as an attribute. It may be so characteristic in the sense, mother cooks rice. So mother has some characteristic and rice has some characteristic. Both are entity. So what are the characteristic mother has? Can somebody tell me what are the characteristic mother has? Can in the chat also you can say. What are the characteristics? If mother is an entity, if we take mother as an entity, what are the characteristics mother has? Yeah, name, age, right? So those are the things characteristic to a mother. So when it comes to rice, what are the characteristics rice entity has? There are types of rices, right? Red rice, white rice. So those things. And what else? The rice has a characteristic. Yeah, price. Yeah. So yeah. So good. So these are the things we called as a characteristic, right? So first thing is entity. Entity is a person, place, thing, concept, or event for which data can be stored. Second thing is attribute. Attribute is a characteristic of an entity. And third thing is relationships. So relationship means, so this is an entity. So that entity has some, sorry. I think my pen is on why. Okay, so okay, let's forget. So this is an entity. Those entity has some attributes, right? So they also some entity, right? In the real world, we don't have only one entity, right? So in that entity also, it has some characteristic. Likewise, in the real world, when we take a scenario, there are lot of entities, right? And those entities have some characteristic, surely. But how can we connect those entities all together as one scenario, one real world issue, right? So that's the thing is relationship. It's then association among those entities. Association in the sense, how can we interact, how can we communicate within those entities is the one we called as a relationship. So when it comes to mother entity and rice entity, within that, the cook is a relationship, right? Cook is a relationship within that two entities, which that relationship only we can connect those entities, right? So let's take president published a gazette. So what are the entities in here? In this real world scenario, it's a real world issue in Sri Lanka, right? So our newly acting president published a gazette. So that's a real world issue. So when we have to convert it into the data models, what are the entities in this scenario? Acting president published a gazette. Yeah, acting president and the gazette is the entities. So what is the relationship between these two entities? Acting president publishes a gazette. Acting president and gazette are the entities. Then what's the relationship between these two entities? Publish. Yeah. So so mostly when you see this example, the entities are mostly in the noun, right? The nouns and the objects are comes as an entity. If we take as a sentence, the noun and the objects are the entities, and the verb is act as a relationship, right? So when it comes to data model, we don't consider the tenses. Okay, just a verb. You can put just mother and rice. You can just put as a relationship name as a cook only. No need to consider the present tense, past tense, and yes, if that's a mother, we have to put is. So no need to consider that. Just a verb. Okay. So I guess you have some clear idea of entity, attribute, relationship. And next thing is types of relationship. So when it comes to relationship, we have so many types, right? So those types depends on the entities which are connected in the two ends. So when it comes to a relationship, so if that is a relationship, it has two ends. One is this entity and the another entity. The two entities which connect a relationship is as a those two is the depending factors of which type of relationship this has. Okay, so first relationship type is one to many. So simply you can either write one to many in this format, or else better to write as one to m. So two means that double dots in the maths also you learned, right? Sorry. My pen is vanishing. I don't know. I put some effects or something. I guess I will clear that in next. So sorry for that. So that double dot we called as a two. So, okay. So first relationship one to many, one to many. So you can either write it as one to many, or you can use the number 1 to capital M, or else you can use, this is the standard one. So commonly we used, so 2 means the double dots in the vertical format, 1, 2, and star is called as all. Asterisk mark is in the software. When we put asterisk, it called as an all. So many. So which mean all together. So what are the things they have when we put as asterisk? So it means all, many. So this relationship you can write. We have to write indicate which relationship. If in the data models we have to create a entity. So the mother cooked rice, mother and rice is the entity, and the relationship is cook. In the relationship, there are some formats I will teach in next lecture, but within that you have to understand in the relationship, you have to indicate what kind of relationship they have, both entities, right? So first thing, one to many means one thing connected to many, right? So in here, we can't indicate when it comes to rice, to mother cooked rice. Mother is the one person, descent is one, but there. So for that, I need some wait. Can you see my whiteboard, right? Can you see? Okay. So let's take an example. A company. Okay. So a company. Don't forget this a company, right? So this is an entity. Company produces cars. Okay. The words are important. Company produces cars. So in here, company and the cars are the two entities, right? So company is one thing, right? One. Sorry. So here, companies one thing. Here cars are the many, right? So when you finalize this relationship, what relationship both entities have, you have to consider the two ends. First end is company produces the car. So cars are many, right? As well as the next end also you have to consider. So uh, cars, uh, so when it comes to cars are produced by company. So when it comes to cars, it may be cars. So when it comes to one company, so in the cars and also, so it can't, cars can't for more than one company, right? So here also, when it comes to cars, it's many, it can be either, it can be connected with only one company. So altogether finalized one is 1. Here also you have to take the maximum one. So here also many. So let's take an example. The next 10, when it comes to the next 10, when that next 10, if that next 10 comes as a 1, not the M, right? So if that next 10 comes as 1, so the highest one you have to take M. So if here the next 10 comes as a many, you have to take many as the final relationship. So the final relationship comes as a many to many. But in our case, it's only 1 to many, right? So it's the final relationship is 1 to many, right? So there are 4 types of, so now you are seeing my presentation, right? Or whiteboard. It's a presentation of whiteboard you are seeing. Whiteboard, okay.
Whiteboard.
Okay. So no issues. So there are 4 types of relationship, right? So first type is 1 to many. Second type is many to many. Third type is 1 to 1. So no 4. So just 3, right? Wait. Okay. So 3 types of relationship. First thing, sorry. So yes, so don't forget that syntax. 1 double dot M, or you can use 1 double dot asterisk sign, right? 1 to many. Second type is many to many. Third type is 1 to 1, right? So 1 to 1 relationship is, do you have any idea to 1 to 1 relationship? Only one instance can happen, either both sides. Can somebody tell example to one? Yeah, so NIC and person. So when it comes to a person has NIC. So one person has only one NIC, no, NIC number, right? More than NIC number. So those kind of, when it comes to relationship, so let's move to the slides. I will, in slides also, you will have some examples. I have to stop. So one to many relationship, so association among 2 or more entities that are used by the data models, we called as one to many. So mostly we use the 1 to M capital, and 1 to asterisk sign also for represent the 1 to many. So one entity instance, so basically we called as entity as an instance, right? One entity instance is associated with many instances of a related entity. So that a company produces cars likewise. So I teach, so lecturer teach students. So in here also 1 to many. From my end, only one person, but your side, you have many, right? So many to many relationship. You can use M to N. Don't forget in capital N, not the M to M, sorry. M to M, it's M to N or both side asterisk. Or else you can either write many to many, you can either write, right? So many to many association among 2 or more. In the both entity instance, it has to connect 2 or more entities, okay? And the third one is 1 to 1. 1 to 1 is it's only one entity compulsorily connect with only one entity from the next 10. So it's called as one-to-one, or else you can write this as the double dot one as well. Okay. So another part is constraints. So constraints means we have some restrictions. Okay. So when it comes to some data things, it has some restriction rather than the usual data types, right? So when it comes to GPA as a data, so normally when we in the database design, what we have to do is GPA, and we give as a number. GPA is a number data type. But when we just give GPA is a data, and that data has so GPA is a attribute. That attribute, so student is the entity, right? Student is the entity, and GPA is an attribute, and that attribute has number data type. Is that enough? No, right? For that, we have to put a constraint. Like if we put a number, they can go for more than 4 or 5, more than 4, right? So that's not applicable when it comes to a GPA. So for that, we have to put a constraint as GPA just only equal or below to the 4.00. Okay, so likewise, we have some constraints. So when it comes to NIC number, we have the constraints, like it must be contain the text as the last letter, or that text must be the capital B as the last letter. Likewise, we have some constraints in when it comes to database, right? So when it comes to telephone number, we have the constraint. It must be. So when it comes to Sri Lanka, it must be 10 numbers. So likewise, we have constraints, right? So far we discussed the basic building blocks when it comes to data model from the real world to computerized system. We want a data model to communicate with the computer applications. So for communicating the computer application, that those data models have some basic building blocks, right? Entity, attribute, relationship, and relationship has 3 major types: many to many, one to one, one to many. And then constraints. Constraints in the sense, we have some restrictions on data, right? Like GPA, NIC number, mobile number. So likewise, you have to put the constraints. Then only that database should be a correct, or database should be the applicable format, right? So if GPA is 5, that is not applicable format, right? So next thing is business rule. Okay. So we have some business rules when it comes to the data model. Business rule in the sense, we have some policies in our organization, right? More than these entities and the relationship and the data types, we have some policies in our business, right? So we have to include those policies to the data model only, right? So here, for an example of business rule is a pilot cannot be on duty for more than 10 hours during 24-hour period. So in that case, when it comes to database design, when we didn't have any business rules, what they have to do is, if there is a database, online database system which allocate the pilot schedule, then if they don't have the business rules for the within the 24 hours, if that pilot has more than 10-hour schedule, then that will affect the passengers, or it may be leads to an accident, right? So in that business rule, we don't apply that business rule to other softwares, right? The pilot may, so like day-to-day coolie person. So for that person, we can applicable that schedule, right? Likewise, each business have some rules, right? So those rules also we have to include in our database design. Okay, so when it comes to that health sector issue, health sector person, so we can I think they don't have nowadays, they don't have that overall that overdue overtime also, they have some limitation, right? So likewise, we have to put our business rules to that database also. So importance of the documenting business rules is, why do we need to document those business rules? Then if you didn't have document that rules when it comes to database creation, so the designers or the end users don't aware of that rules, right? So you have to document the business rule. So it helps to standardize the company's view of data, and it can be a communication tool between the users and the designer. So users means when it comes to that pilot system, users are the pilot managers, supervisors. Pilots are the users. Designer is the one who collect the data. So in that scenario, that in within the 24 hours, that more than 10 hours they don't assign to a pilot is the business rule. If that rule didn't document properly, then the schedule may be affected, right? And third thing is, it allow the designer to understand the nature and the role and scope of the data. So it's all depends on documenting the business role. Okay. So if you don't document those stuffs, then each time those designer needs to communicate all the end users, and it takes so much of time, as well as it takes some improper or wrong data collection as well. So you have to document your business rules. So the final thing is translating your business rules into data model. So data model, we have some basic building blocks. So now we have the real world scenario. So those scenarios we called as business rules. Those business rules need to convert to a data model. So while converting, we have some rules, right? First thing is, as I already discussed, a noun is in a business rule will be translated into an entity in the model. So basically model in the sense data model. So noun in the business rule are converted into entity, and verb in their business rule are converted into relationship. Okay, so likewise we have some business rule conversion rules also. So here a customer may generate many invoice. So this is a documented business rule. So when it comes to that translating this business rule into data model, then what we that customer, it's a one to many, right? So the relationship in here is one to many. Is that okay? A customer, they clearly say a customer, so it's one. Here many invoices, so it's a many, so it comes as a one to many, one end. Another end, invoice, one invoice can if one invoice can so can many customers can create a one invoice? No, right? So it's next end also one to so better to share my mind. Did you get this one? Wait. So please consider this. This is the important thing. So when there is what's our business rule? A customer, right? So a customer may what this one? A customer may produce or something, right? Yeah, generate. A customer generate many invoices. So the one end, so you have to check both end. After that, finally you have to come up with the what relationship, right? So in here, first end, customer, one customer, right? So one customer generate many invoices. One to many first end. Second end, from the invoice perspective. So when we take one invoice means that receipt, right? So that when you buy something in the supermarket also they produce one receipt for product, right? So that one receipt, uh, one invoice, only one invoice was produced, generated by only one customer, right? So in this end only 1 to 1. Is that clear? This one is clear or not? Or else I have to treat it. So finally, what is the largest one? 1, 1. So that's a final relationship is 1. Here 1 and m, many. So final larger one we have to take. But which is the final larger, many. So the final relationship is 1 to many. Is that clear? So if there is this is an entity, so here also another entity. The relationship from, this is an example, right? Relationship from one end is many to 1. And the next end is 1 to 1. What is the final relationship in for here in the chat? Or unmute yourself. So there are two entities. One entity, one first end, it's many to 1. And the second entity's perspective, 1 to 1. So what is the final relationship? Yeah. Is that okay? Yeah. Okay. So you got the point. No, many to many, no. Many to 1. Here, many and 1 here. So the larger one we take, many. Final. So here 1 and 1. So the larger one means same, right? So the relationship is many to many. Sorry, many to 1. Okay. Desan, right? Not many to many. It's a many to 1. So if right, there is two entity, the one entity. So you have when you have a business rule, you have to take either first perspective as well, second perspective as well. You have to check. That's the third rule, right? So here, this is 1, and this is first perspective is 1 to 1. Second perspective is sorry, many to many. Second perspective, many to many. How can you write? Here m and here n, not m, right? Many to many. Second perspective. So what is the final relationship in here? There is a two entity. First perspective is 1 to 1. Second perspective is many to many. So what is the final relationship between these two entities? Many to many. Yeah. Okay. So here, the larger is here many, and in here also many. So it comes as a many to many. Many to many relationship. How can we write? M to n, right? So all capital, don't use small. Yeah, fine. So I hope you understand. So that's the third rule. Wait, I'll share my screen again. So first rule is all the nouns in the business rules are entities and the verb in the business rules are relationship. And second thing is to properly identify the types of relationship, you should consider that relationship are bidirectional. So that is they go both way. So in here, a customer and generate invoice is the one way. Second way is an invoice is generated by customer. So in here, whatever the instant entity in here, many or one, you have to consider as a one to how can generate like how can so lecturer yeah like so there is an example. Lecturer teach student. You have to consider lecturer. So I'll put it in the chat. Lecturer teach students. Here, so what's the relationship? Okay, so one to many because one lecturer can teach many students, and the next perspective also one student can learn from one lecturer as well. Both perspective you have to think. But when it comes to wait, okay, so subjects. Okay, so I don't. So I will find some exercises in the next lecture. So I forgot. So 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 this is the so here also yeah it's finished. Yeah, one too many. So the already we discussed things. So to properly identify a relationship type, you should generally ask two questions. First thing, so when it comes to, you can see my screen, right? Yes. So when it comes to two entities, A and B, so the business rules, first business rule is right as A and B direction. So you have, when you have to finalize the relationship, you have to think both way, A to B, and then B to A also you have to consider, right? You can assess the relation. So yes, okay. So this is one example exercise. So we will so just discuss this one. Okay. So first thing, manufacturing company. So when in the questions, when they give the scenario, you have to read those scenarios clearly. Then you have to divide the sentences in that scenario. Then only you can create the data model properly. Okay. So here it's a manufacturing company produces products. So here one sentence divide. The following product information is stored. These are the information stored, right? So a product has some product name, product ID, quantity on hand. So these products are made up of many components. Second sentence is there. Okay. each component can be supplied by one or more suppliers. Third business rule. The following component information is kept. Component ID, name, description, suppliers who supply them, and products in which they are used. Okay, so wait, I don't give any figures here. So just discuss with me. Okay, so here, what are the entities are here? So before going to the entity, so how many business rules are here in the chat? How many business rules? So I serve your chats. So when end up the session, your chats are automatically saved. So I will see who are the persons who answered with me. Okay, so it will added in when it comes to the final assignment marks. If you have less marks, I will add extra marks using this chat. Okay, so if you know answers, just put it in the chat. Oh, I have the recordings. If you unmute and tell, I will note your name. Okay, so here business rules are there and attributes are there. So first thing you have to consider, what are the business rules, right? So how many business rules are here? Put it in the chat. How many business rules? Business rules in the sense that sentences which can be converted as a data model. How many business rules here? How many business rules in here? Sandhani, 4. Others? It may be wrong answer. Just read the paragraph. Business rules mean you can convert those business rules as data models. So how many business rules? Are there any different? Yeah, okay. So 6. Oh my God. So I think 3. So let's check. I don't know the answer, right or wrong. So first thing, sorry. Manufacturing company produces products. I will highlight. So this is one business rules. And the following product information. So that product is an entity. That product has some attributes. So these are the attributes, right? So those didn't comes under the business rule. So only one here. And second things are the attributes. I avoid that. Third sentence, these products are made up of many components. So here also one business rule. So I highlight second business rule. And third is each component can be supplied by one or more suppliers. So the third business rule. The following component information. So that's also an attribute. So how many business rules are here? Only 3 business rules, right? So whoever consider 4, 5, 6, please think about it. Okay. So here only 3 business rules which can be converted as a data models. But those 2 sentences are the more information about those entities. For one entity is the following product information. So the entities here, what is the entity? Product. So product is an entity. And product name, product ID, and quality are the attributes, right? Product name, product ID, quality are the attributes. And here component. So component is an entity, red one, second entity. And that component has some attributes of component ID, name, description, suppliers, and products. Okay, so wait. Products in which they are used is not consonant. Okay, so here the final one is we will discuss this. This is also one attribute. That attribute also one entity. So product is already there as an entity. That entity comes as an attribute to another entity. So that's a special case we will discuss on. So this is not a business rule. So this is one of the attribute. Here they clearly told us the following component informations. This is the full stop. This is the sentence start. So this is also one attribute. But that attribute already we have as an entity. But that's a special case. But that's why I told when you have some scenarios, first you have to divide sentence by sentence. So that only I give as a paragraph to confuse you, right? So using the full stop, you have to divide those paragraphs as a sentences. So this is one sentence. So this sentence all talk about an attribute of a component. These are the attributes. Okay. Don't confuse. So you have 20 minutes. So I will give do you have any other lectures on 12?
No, madam.
Okay, then I will give 30 minutes, but that's too large to you. So I will put it in your breakout room. So each group come up with your like this. First you have to first you have to identify the business rules. Then you have to identify the attributes. Then within the attributes, you have to identify the relationship. So here also, the manufacturing company produces products. So manufacturing company is an attribute, and products are one attribute. Producers are the relationship, and there you have one to many relationship. Likewise, you have to come up with you have to come up with the how many business rules. Okay. Second thing, you have to come up with the each business rule. You have to come up with the entities, relationship, and the so you can get a Word document, right? In each one of you, you can put a Word document and you have to submit to me after end of the session, right? So just put a word, first thing, business rules, right? Wait, I will create that. I will share my screen. So don't worry, I will give you 30 minutes. It's enough. Okay. So yeah. So first thing, I will divide you as a breakout room. Earlier I divide. So likewise, I will divide you into breakout rooms. So each breakout rooms, I will send you this Google form, right? This Google Doc link, I will send you. Before that, I will send you the question also. So I will put that question is here. So this is your question. So here I divide your business rules, but in that sentences, you have to decide whether they have the business rules or not. So this is the question. Okay. So in here you have first you have to come up with business rules. How many business rules are there? You have to put the number. Okay. Second thing, you have to come up with the so just put 1 to 3. Right. Okay. So in this one, so first thing business rules. Second thing, you can put 1 and you can put in the shapes, insert shapes. Oh, okay, no need that. So 1 and you can tell me as an entity, name of entity, and then name of relationship. First entity, second entity. Likewise, you can. First entity, relationship. Second entity, then relationship type. Okay. So I will share this with your group. Point wise, you can divide all. So finally, you have to come up with all the entities and relationship. But you can put 1, 2, likewise. If you have 2 or more sentence in one, I don't think I have put. So if you have 2 or more business rules, just put 1A, 1B, likewise. Okay. So I will share this link. So also you have to put your registration numbers wherever in the doc also. Okay, you have to put your group all members registration number here. Okay, so this is a Google Sheet, so you have to work online, then it automatically serve, right? No, wait. Okay. I will, so likewise, I will send each groups, I will send go form link, right? So no need to worry. So, it's 11:46. Or else just give me a minute, I will make a copy and send. Group 2. Make a copy. Group 1, group 2. Make a copy. So I will divide you into 4 groups. Okay. Remember, put your register numbers. I will consider this as an assignment. Okay. So, okay, so all good. So, wait. So I will share the link for each groups in the group chat. Once you go to the breakout rooms, your groups, you will have your Google form to your group, right? So just update.
පස්සම ගැහුවනේ.
So if you want any help, you can ask help from the breakout room. I will join. Okay.